So let's get started. The first question, I choose the easiest one because we are in the introduction chapter of the array, right? Let's see. It is max consecutive ones. According to the description, it given a binary array length. So there are two things inside here. Given means they will input some data, and the data type is binary array, and the name is nums. So we need to write code here inside the class solution and inside the define function. It done for us, and we need to finish here and then return the maximum number of the consecutive ones in the array. So let's see the example. The first example, it input nums. The list, what inside the list is 1101111, and it expects us output 3, and the explanation is here. The first 2 digits and the last 3 digits are consecutive ones. So let's see, 1, 2, there are 2 consecutive ones. 1, 2, 3. There are 3 digit consecutive ones. So the max number of the consecutive ones is 3. So let's see the second example. So intuitively, it is easy, right? It is 2 digit numbers of consecutive ones. So the output is 2. Finally, don't forget the constraints. The first constraint is the length of the nums is greater than or equal to 1, less than or equal to 10 to the power of 5. And the second constraint is the element is either 0 or 1. Because the question is so simple that we can even use our intuition to fix them. And the approach I use here is called one pass. We just keep a count of number of 1 we encountered. Whenever we encounter any other thing than 1, like this is a 0 in these problems, because we are in a binary array and there are only 2 elements, so whenever we encounter 0, we reset the count to maintain the counter of continuous 1 between 0. Let me make an analogy. It's a bit like tracking a sleep of number of hours you sleep, like sleep, wake up. So this wake up break down your continuous sleep. And let's turn our intuition to an algorithm. We set a counter, and the counter is count the numbers of ones. Whenever you encounter ones, it will increment the counter by 1. But whenever you encounter 0, the current count of ones compare the previous count of 1 to find the maximum contiguous 1 till now. So afterwards, we reset the count of 1 to 0 because we don't need the smaller one. We only take the bigger one to find the maximum contiguous ones. So after all, we find the maximum contiguous ones. In the end, we can return them. So we're done. Let's look at this diagram. First, we need to initialize the max count is 0, and the count is 1. Why? Because when we count and then we meet the 0, so the consecutive 1 is only 1, and because when we meet 0, the max count is calculated. The max count, as we see, is before is 0, and now is less than count because count is 1. So the max count is equal to 1 because we assign the count to the max count, and then the count is reset to 0. And let's see, let's skip this 0 and keep moving on, right? And 1, 2, 3, there are 3 consecutive 1 until we meet 0. So the count now is 3, but the max count is equal to 1. And now, because we encounter 0, so let's calculate the max count. The max count 1 is less than count, because the count is 3. So the max count gets the value from count. It now becomes 3 now. And then we reset the count to 0. And let's skip the second 0. And 1, 2, the count is 2. But the max count is still 3. So we can compare. The max count is greater than count, and the max count is equal to 3 because it is larger than count. We don't get the value. So finally, because we finished, so the max count is equal to 3. We need to return this value. As the above diagram shows, we find that the max number of the consecutive one is 3. Well, when we iterating the array, we encounter 2 breakers in this count. Every time we encounter 0, it will break, and we had to reset the count of 1 to 0. I mean the value of the value of the count is 0. And when we account 0, it breaks. And at the same time, the max count is calculated. And in other terms, the 0 break down this array into a sub-array with the consecutive ones. So let's try to turn the algorithm into code. When we meet 1, it account 1, the first one, the second one, 1, 2, 3, and if name equal to 1, we count 1, right? So it is increment 1, right? And else means we encounter another element, and another element in this problem is 0. Else we need to, because we meet another element, so we need to count the consequent digit of the ones. So the max underscore count equal to, we need to give him a max function, and inside the max function there are element we can compare. We have a max underscore count and count, and before that we need to initialize count and max underscore count, initialize them to 0. And don't forget, else we have to reset every time after we finish compare and get the max underscore count. We need to reset the count, reset its parameter to 0. And to finish this, don't forget we are in a for loop. For len is the element name in the lens. This is the list len. We are inside for this for loop, so we need to give this indentation. And we finished. We have to return the maximum number. So we use a max function again. Inside the max function is also a max underscore count and count. So we are finished. We can give him a function. Define find max consecutive ones. The parameter inside is a self and a list is lambs and a list. Inside list is an integer, and we need to return after finish. We need to return an integer. So we are done, and this is inside this function, and this function is inside a class solution, and give him a indentation. Then it's no problem to run out, right? Let's print some input data. Print solution dot find max consecutive ones, and we can give him two input data, and the input data is still, let's see, the first one and the second one. Yeah, 3, 2. That's perfect. We are done.